Good afternoon, guys. Hopefully you're having a lovely day. It's time to look at some substitution. For those of you who were absent last week due to whatever was going on, whether it was the Keith Hawkins presentation or the PSAT, one of the topics you might have missed during class was substitution and solving systems of linear equations. The idea of substitution is reasonably simple. I'm sure you guys can handle it. Basically what we want to do is we want to notice that in this particular equation, it says that y is equal to or the same as 6x minus 11. The idea of substitution is when you have a variable that's been solved for itself, you're going to replace it. It's almost like they're synonyms, synonyms that taste better. You replace the value that's equal to one of your variables into the other equation. So here what we're going to do essentially is take the value of y, which is 6x minus 11, and we're going to place it in for y in the other equation. Just a direct substitution. Let's give this a shot. If we take that equation, all we're going to do is replace the y, nothing else. And what's nice about this method, especially if something's been solved for you, is that now if we look at this equation, the only variable that we have to deal with is x. The y is gone. But once y is gone, once we're down to one value, or one variable that we're looking for, it's easy enough to solve. Follow the normal PEMDAS rules. We'll start by distributing. So negative 3 and 6 will be negative 18x. Negative 11 and negative 3 will give us positive 33. Then we can combine like terms. Negative 2x minus 18x is negative 20x. And solve it like any other equation. We'll subtract 33 from both sides. And at the end, we'll divide by negative 20. In this manner, we'll be able to find the value of x without doing anything crazy. If you recall, the reason we look at these methods is because sometimes trying to graph these equations can be very difficult to see when it's not an exact value. Now, the key here is once we've found one of the variables, for instance, here we found that x is 2, that we need to then take that value and plug it into any of the functions we handled already. I'm going to choose our first function because it looks like it's pretty simple. So if I take y equals 6x minus 11, we can plug in that 2 for x. And solve it directly. And once you're done, just give me a square on both of them so I can see them and you found your answer. Again, the idea behind this method is if one of the variables has been solved for, if it's already alone, we can take its quantity, plug it into the other equation, and solve it directly like an equation we've dealt with in the past. Let's try another one. If you'd like to give this one a shot before I work on it, go ahead and pause the video here. I'll give you a couple of seconds. Okay, I'm going to assume if you actually want to try it before me, you've already paused it. If not, you've already finished it, or you want to take a look at it with me before you work on your own, which is fine. If we look at this particular system, we'll notice here again, y has been solved for us. It's equal to x minus 1. So we're going to go ahead and replace the y in the first equation with the y, the y in the first equation with the y in the second. We're going to give up on that little trick, sorry. But the math remains the same regardless. If we pop in the y, we'll end up with a similar thing to what we had just a moment ago. And we'll follow the same exact procedure. We'll distribute, giving us negative 3x plus 3 equals negative 1. We'll combine like terms. We'll subtract. And then at the very end, we'll divide by negative 1 to make sure we have a positive x. We do need to make sure that that is indeed finished fully. And we'll sneak him in right here on the bottom. Once we've found the one value, we can go ahead and plug that into any equation. Again, I tend to think the y equals x minus 1 is probably the easiest here. There's no purpose in giving anybody any extra work. So we'll go ahead and use it. This is actually a reasonably easy calculation. So you found your y value is 0 and your x value is 1. Keep in mind that solutions to systems are always points. There's some intersection, such that if I have some graph, and hopefully my graph is straight. If I'm placing two lines on it, Wherever those lines intersect is my solution. So in this case, that would be a solution. Because the solution is a point, it has two coordinates, and that's why we need to solve for both x and y. Now, of course, like any other problem, there's always a monkey wrench that I can throw at you. If we take a look at this particular problem within our two systems, we can see that none of the variables have been solved for us. We have at this point two different things we can look at. We can either switch to a different method like elimination or graphing, or we can meet the condition ourselves. Specifically, if we look at this problem, and we look at this very first equation, okay, what we'll hopefully notice, aside from being unable to read the y, is that it would be relatively easy here to move the negative 5x over to the other side. Think about it, if we got this guy over here, the y would be alone. And it's kind of nice to work with him because there won't be any division left over. The y will be alone immediately. So let's actually work with him pretty directly. Okay? So basically all we have to do is add 5x to both sides. And that'll get the y alone. Now that y is alone, we have the same situation as before. We can take this 5x minus 7 and plug it in to this y over here. And we'll find the value of x. Oop. Wouldn't be a fun video if something to get a little funky. Okay, so we'll distribute. We'll combine like terms. And I know you're probably getting tired of hearing it over and over, but we'll subtract, and then we'll divide. And in this manner, we should be able to find the value of x with relative ease. In this case, it looks like the value is going to be 2. Just like before, we can pick any equation that we're working with to find the value of y. I'm going to take the y equals 5x minus 7. It just looks like it'll be the simplest and the most direct. Just plug in your value. And you're done. Okay? So again, if there isn't a variable already solved for on its own, you can simply take one of the equations and put it into that format. As a quick wrap-up, remember to get the variable alone, substitute or replace it in the other equation, and then plug it in again to find the other value. See you guys tomorrow.